Hi guys, this is a fan regulator and this is a ceiling fan. This is actually a faulty fan, but I'm going to use it to teach us everything about ceiling fan connection and how to go around, find your way around problems arising from your ceiling fan. So we'll come to this regulator later. So just bear in mind that this regulator is like a switch, a variable switch. It has 5 speeds. So it's controlling only one line, one of these supply input, just like a normal switch is controlling one terminal of the lamp holder. So this is also controlling just one line, while the second line gets neutral straight from the distribution board. So we'll come to this later. Let's pay attention to this. So this is a shock absorber. So ceiling fans do have a hanger. So this shock absorber, you first sit it on the hanger, then you insert this metallic holder, okay, hang your fan and then lock it with this stuff. So but this is a very minor thing we can always do. So your major concern, when you be concerned about this, is when you want to pull down the fan or when you want to hang a new fan. So but if your fan is having an issue, it's not spinning, so these points I'm going to talk about now are where we have concern. So this is the input terminal at the ceiling. This is the input terminal. One terminal is neutral straight from the distribution board or any other neutral point, while this terminal is the live terminal that is speaking from the fan regulator. Live from the DB comes to the regulator, then from the regulator it passes varying amounts of electricity to this very terminal. So we have different speeds. If it's a high speed, it's passing high current to this terminal. If you set it to a lower speed, it's still lower value that will enter here, while neutral is just straight to the distribution board. So this is the supply input and it comes to this place. So I will show you what is happening here. Just pay rapt attention. So guys, these are these two input terminals. These input supply terminals, they are terminated here. Okay, so you can see them. These are the two terminals from the ceiling. Okay, so they come here. Then we have this capacitor. This is called a capacitor. It has two terminals as well. So if you observe, let me loosen this so that we can see it clearly. All right, I think we can see it better right now. So this is our capacitor. You can see the terminals of the capacitor. So bear in mind that every fan, in fact every electric motor has single phase. Now every single phase electric motor has 3 wires coming out from their electric motor, but the electric motor of this fan is badly burnt. So this burnt part is coming straight from the coil. Okay, so 3 wires come out from the coil: red, black and white. Okay, so before you can master the connection of the fan, just bear in mind that one leg from the electric motor, now one terminal from electric motor, will go straight to the supply. Okay, we call it supply alone. These are the 3 cables from the electric motor. One goes to supply alone, one is called capacitor and supply. All right, so this is black from the electric motor. It has contact with the capacitor, and from here it has contacts with the supply. So this is the capacitor and supply, and the third one is called capacitor alone. So they use this white color for the capacitor alone. So you can see this terminal has contact with only one leg of the capacitor. I will come again. 3 wires will always come out from a ceiling fan like this. For any electric motor, most single phase electric motors, you're going to find 3 wires, and we usually employ a capacitor. I'm going to explain what this capacitor is doing, but let's just understand the connection first of all. So we have supply alone. One of the 3 from the electric motor, we have supply alone. This has contacts with only the supply. Remember, this is the supply, live and neutral. So this is the supply alone. Then we have supply and capacitor. This is from the electric motor. This is the supply and capacitor cable. You can see the capacitor, it has contact with this supply and capacitor. It has contact with the supply as well, right? So this is it, supply and capacitor. So it's the supply and capacitor terminal of this electric motor. Then the third terminal is capacitor alone, which is the white one that has contact with just one leg of the capacitor. So this is the arrangement. So just bear this in mind. Okay, so in order not to get confused, before you detach, maybe if you want to change a capacitor, if possible, take a snapshot of this termination to master where each wire goes. Okay, so you can actually find out which one is capacitor alone, supply alone, or that using a multimeter, but that is going to be kind of confusing to some people. So but the simplest thing to do is if your capacitor is swollen, that's the greatest or the highest, the most lucid sign that your capacitor is bad is when it swells up. You can simply detach it from here, find a replacement, and put back to the initial position. So that's if your capacitor is bad. So for you to find out the exact position, I recommend you take a snapshot, or you label this as the supply alone, you label this as capacitance supply, you label this as capacitor alone, so that when you want to replace the capacitor, it will be very easy for you. Now, let's say your fan is not spinning. Let's say your fan is not spinning. The first place you should check if this place is connected and you've confirmed that the regulator is in order, you test for voltage here. This is the first point of the live and neutral. You test for voltage with your multimeter inside these terminals to confirm that it's supplying voltage here. If you get voltage here, know that your regulator is in order and it is supplied, okay? Then the next thing to suspect is your capacitor. And most of the time, if your capacitor is bad, you'll be hearing a hum sound and the temperature of this coil will become very high. You'll be hearing a hum sound and the temperature will be high, or the fan will be spinning slowly. So these are the signs that your capacitor is bad. So, but if you're not hearing any sound at all, the temperature is not high, or it's just hot and is not spinning, so you start to suspect a bad or a faulty coil. Okay, so but before you do this, I recommend that you detach it completely from the supply. If you detach completely from the supply, when the electric motor is in order, all these three terminals will read continuity with your digital multimeter. Set it to continuity. The three wires coming from the electric motor will read continuity. So if any of them is not reading continuity, know that your electric motor is bad. Then if it has earth leakage means if you are reading continuity between a terminal and the body of this material, if you see any continuity reading from any of these terminals and the body of the fan itself, just know that your coil is bad. Okay, so but if you rotate this fan, like mine is very stiff, it's so stiff due to rust and a number of factors, so what you can do is to apply lubricant at this junction, at this joint, see if it gets free. If it does not get free, you have to detach it completely and change the bearing, but this is a kind of complex situation. So but the most obtainable problem is usually a bad capacitor. So if the capacitor is bad, you can always replace the capacitor. Okay, you replace the capacitor. If you don't get voltage here, you trace back to your regulator. So for now, the aim is to teach us how we can check or replace the capacitor, and then if it is stiff, you apply lubricant. Okay, so if you apply lubricant and it's still stiff, it's going to warrant changing the bearing. Okay, so changing the bearing, which may be a little of an advanced problem. Okay, all right. So if the coil is bad, is an advanced problem, but although I'm going to show how to rewind this very coil and subsequent material, so but for now we should be concerned with how to change the capacitor if the capacitor is bad, how to apply lubricant at this junction to see if it loosens up, and then how to check your fan regulator if it is bad. So let's go to fan regulator and see what happens there. This is inside a fan regulator. We have two live wires here, or two red wires. One of these wire is coming directly from the distribution board, and one is a branch from the fan itself, just like it's a switch. One from the common, one from the DB to the common, and the second terminal is the live terminal of the lamp holder. So that's the same thing that is happening here. So one is supply from the DB, then the second one is live to the fan, while the fan picks neutral directly from the breaker or any other neutral point. So what now happens here is that we have a potentiometer. This thing is a potentiometer. In the olden days, it used to be a multi-tap transformer. So what is happening here is that this potentiometer has variable values. Okay, so the terminals have variable values. I don't know if you can see it clearly. So if you switch it to speed 1, speed 1 has a varying amount of current it allows. If you set it to speed 2 up to I think 5 speeds. Okay, so it will be taking this branch from the fan to taps of different current or voltage values. All right, so But if you connect it straight, it's not going to have any regulation. It will just be spinning at its maximum speed. So a potentiometer varies the amount of electricity it passes out. So that's just a layman's explanation of what a potentiometer is. So at this point now, if you switch the knob, if you switch the knob of this fan regulator to this blue point, it's going to allow a certain amount of electricity to flow from this cable into the fan. If you switch it to this black terminal here, it's going to allow a particular amount or a particular value of electricity to flow to this point into our fan. If you set it to this point, they have different values of electricity. So this particular device here is doing the job. It's called a potentiometer. So it's only live. What we have inside there is only live. So if any point is not working, so you just change this fan regulator. Okay. So, but what you have to confirm is that the live supplying from the DB is true. The lifeline is energized. Okay, so you can look for neutral at any nearby, maybe from a socket or any nearby neutral, to confirm that there is voltage between this point and that neutral line, to confirm that this place is supplied. So if you are not getting electricity here, automatically the fan is not going to function. So you trace back to the distribution board where this supply is coming from, right? So this is just what happens here. So but if there is light here but these terminals are not delivering, just know that your regulator is bad. You just simply buy a new one. So that is what happens here, guys.